Let alpha be a positive real number, and then let f r to r and g alpha infinity to r. So these two are a representation of any function in the terms of domain and codomain. So if I talk about f r to r, then it means that this part is domain. See, fine. And this part is codomain, and the subset of codomain is R. Sometimes it is these codomain and range are equal, but in the most of the cases, the functions are that are generally framed are having range as a subset of codomain. So, and these two functions are given, and these two functions are defined by fx is this and gx is this. We are asked to find the limit at x tends to alpha plus of f of gx. So why you can think that why there is mentioned x tending to alpha plus. So alpha plus means that the limit is coming from taken from right hand side, not from left hand side. So why they have mentioned that alpha plus? Why they had not mentioned x tending to alpha? Listen, that G is defined for only to domain from alpha to infinity. Fine. So if I replace, suppose if I write x tending to alpha f of gx, so it means that x tends at alpha, limit exists. This means that the x tends to alpha, the composite function that is f of g will have a existing limit. So it means that its LHL, means left hand limit, and RHL, and which is right hand limit, will both exist there and both will be equal. But in domain there is only alpha to infinity. Still alpha is also not included there. So you should think that, then I think that you have gotten the idea that alpha plus is uh, correct representation. If I talk about alpha, then we have to take consideration both the LHL and RHL. Since LHL is not valid here in the case because that G alpha is not defined in the negative x-axis, so that's why they had mentioned here x tending to alpha plus. Fine, but in generally calculations we used to put alpha here. We don't know what is alpha plus, but we just approximate for evaluation alpha plus to alpha. Fine. Okay. So I think that you in when you have study limit, then you have uh, studied about limit for composite function. So limit for composite function is says that if if limit x tends to alpha gx gives us b, then limit x tends to alpha f of gx will give us f of b. But one important condition is there, that f of x, the function, must be that f x must be continuous at x tends to x is equal to alpha point. At x is equal to alpha, fx must be continuous. Fine. So this must be uh, make sure condition for the application of this concept of the composition function. Fine. So if I talk about fx, what is fx? fx is sine pi x by 12. So here x is sine function. Actually, sine function is continuous. It does not grow anywhere. So at x is equal to alpha. Alpha will have some finite value. Alpha will have some finite value. Fine. So then fx is not going to break at that point, even any point in the domain which is mentioned in the G. It is not going to break any at any point. So this concept can be applicable here. Okay. So one more thing I had to introduce here is that limit x tends to 0, e to the power x minus 1 upon x will give us value 1. I hope that this value of standard limit you had calculated, and you are very well aware of it. You can just get this by expanding e to the power x by using that Maclaurin series. I hope that Maclaurin series are not uh, still in the syllabus. So you can use that expansion e to the power x, and after that when you will put the expansion of e to the power x, the one from the expansion and this one will be cancelled, and take x common from numerator, and then x will be cancelled and 1 will remain. After that, apply the limit x tends to 0, the limit will tends to 1. It will give an exact value that is 1. Okay, so let's move on to our question, which is f of gx. So if f of gx will be sine pi by 12 gx. Okay, so first of all let me calculate limit x tending to alpha plus uh, gx. After that we have to just put a value here, that we have to just put the value that this limit will give in the f of gx. So what is gx? First of all, gx is 2 log to the base 3 limit 2. I'm writing as it is a natural log root x minus root alpha upon ln e to the power root x minus e to the power root alpha. I have initially mentioned that this concept because I will be using in between, so need not to think that why before solving why this concept came here. So after that, so if I suppose here alpha and here alpha, then we are getting here uh, minus infinity and minus infinity. So you may think that this is an infinity by infinity form, infinity upon infinity form. Generally in limits, when we get 0 by 0 form or infinity by infinity form, we use L'Hopital rule, which says that differentiate numerator with respect to the variable and differentiate denominator with respect to variable till it vanishes to give this form infinity by infinity or 0 by 0. Okay, so if I if I apply L'Hopital here, so it will be giving 1 upon root x minus root alpha into 1 upon 2 root x. Root x will be differentiated further by chain rule, and in this question, in this part, e to the power root x minus e to the power root alpha, um, here e to the power root x will be differentiated once more, and after that this will also come there in the profile. So we can see here that this part and this part is cancelled. Okay, so limit extending. So after moving further, so converting it to a fraction, simple fraction, so there will be e to the power root x minus e to the power root alpha upon e to the power root x in bracket root x minus root alpha. Okay, after that this limit extending to alpha plus will be something like that, e to the power root alpha minus root x minus 1 upon root alpha minus root x. Okay, so we can see in our standard limit that this argument was tending to 0 and this variable was also going to 0. So let me do one thing here. If I suppose here root alpha minus root x is equal to 2t, then limit will also get substituted that root alpha minus root x will be nothing but equal to t tends to 0, because this particular limit is making this particular argument in this particular variable as 0, so it must make this uh, this fractions as satisfied as this was having. So uh, now you can understand that we have discussed that this is standard limit. Just apply directly here. So what is going to come here is 2. Fine. So we have to calculate limit uh, limit x tends to alpha plus f of gx, which is nothing but equal to uh, f of that limit which came here. We have to just use that limit which is 2. I had discussed this concept here. This, so f2 will be sine pi by 12 into 2 will be sine pi by 6, and sine pi by 6 Sine 30, sine 30 is zero point 0.5. So our answer is zero point 0.5. So if still there is any doubt left here, you may ask in the comment section there itself. I will answer it surely. So thank you and have a nice time ahead.